Alright guys, this video will cover configuration of UART Communication Protocol with two STM32 microcontrollers. UART is full duplex serial communication protocol, which means that sender and receiver can send and receive at the same time, which does not work with clock anyway, but baud rate. The sender and receiver baud rate must match on both sides. All right, let's create a new project. I've selected the board I'm using. I'm using F44R6RE here. This is the sender's project. I will give Tx. I will clean the pins. Here I will use the internal clock. I will set the system clock to run at the maximum 180 megahertz. So go to connectivity, and we have a lot of UARTs up to UART 6. So I will choose the UART 1. I will set it to asynchronize, which does not need clock. The parameter settings, the baud rate I will set to 115,200. The word length 8 bits. Parity is none, and stability is 1. The data direction is receive and transmit. So I will add the DMA and also on the NVIC settings, which is the interrupt. So I will set PA5, which is a LED. We'll set to output, and our user pin, I will set it to input so that we can read the button. I will save and generate code. So here I will include the string header file in case I want to use it, and I will also include the stdio in case I want to print something on the screen. Here I will define the buffer, the Tx data, the data we are going to send to the receiver. This is the buffer that will contain the data. So here we are going to read the button, the user button. Remember that the button is connected to PC13 pin. So we are going to read that button. When that button is pressed, then data the buffer we define above will contain some data which will be sent to the receiver. So once the data is pressed, the Tx data, the buffer we define above, we have the value of 1, but if the button is not pressed, the value will remain 0. So when we have the value of 1 in that buffer, we will now send it to the slave, to the receiver. So we send 1 to the receiver when we press the button. So here we will send the data to the receiver. If you actually want to send data in interrupt mode, you can just change this function to change it to IT mode, to interrupt mode, as well as DMA. So here I'm going to send data in DMA mode. So we are going to create another project for the receiver. The same way I created the transmitters project. I'll clear all the pinouts. I will also use the internal clock, HSI. So I will leave the parameter settings as default. Like I said, the baud rate of the both sides must match. I will set the LED pin to output. Here we don't need to configure the button. So I will define the variable that will receive the data from the sender. Here I will receive the data from the sender. So after receiving the data from the sender, I will check if we receive 1 from the sender. We will now on the LED pin, the pin we set as output. that is user LED. The LED on our board is connected to that pin. So after receiving the data, we check if the data is 1. Then we will now turn on the LED. But if it is 0, the LED will remain off. So that is what we are going to do here. Now it is time to build our code. We'll build the receiver's code. Then we need to run the sender's code, the transmitter's code. We need to run it. I'm using the same PC for the two projects. So I need to run it, run one and debug one. So I will now debug the receiver's code so we can view the data received. So now we will go to live expression. We will add our RS data, the variable, so that we can see the data received. So click the resume button. Then we will now press our button. As you can see, the data is received. Thank you for watching.